Under the ongoing social trend toward carbon neutrality, electric power networks are undergoing a major transformation. Now I'm going to talk about exploring high voltage and discharge phenomena with light. My research area covers high voltage, electrical discharge, and insulating material. As for applications to society, it is largely related to electric power networks. Under the ongoing social trend toward carbon neutrality, electric power networks are undergoing a major transformation. What this means is renewable power sources such as solar power and large-scale offshore wind farms. The nature of this power source is different from that of conventional power sources. We need to develop technologies to transport electricity to users. The objective is to come up with a power system that can achieve carbon neutrality. And what is important in the hardware is the insulation technology and the interruption technology. Insulation technology allows electricity to flow only where and when you want it to flow. Interruption technology is a technology that cuts off the electric current. In other words, it is a technology that prevents electricity from flowing when it should not and cuts off electricity when it should. Both insulation and interruption are technologies to prevent electrical discharges from occurring. In order to control the discharge, we still need to observe what is happening in the discharge. So, what kind of tools should we use to measure it? The most convenient tool is light. This is an example of using a sensor made from the crystal. Actually, this is a sensor that we made 20 years ago. We attached an optical fiber to a crystal and inserted it into a space where electrical discharge is occurring, and measured the electric field that was applied there. Although electric field sensors have not yet been developed, sensors that measure current on sensors that use optical fiber to measure strain are being developed as a series of products. I believe we will soon have standards for sensors that measure electric field with light or using optics. By using optical diagnosis as an unconventional tool, we were able to measure such discharge parameters as electron density, temperature, and electric field. And this would be a very useful data for those who use discharge or for those who want to prevent discharge.